Welcome. Today we're doing section 9.4, solving rational equations. So now we've been simplifying rational expressions, now we're solving the equations. The first one, simply isolate x, quite simple. Subtract 7 and divide by 3. So you get 15 and then divide by 3. We get 5. There we are. Second one, add the 6. But now we have this denominator. So normally what we would do is multiply by the reciprocal so that they cross out. 12 plus 6 was 18, and it's being multiplied by 3 over 2. The 2 is going to turn the 18 into a 9. 9 times 3 is 27. Okay, this last one, 3/5 x plus x minus 1 over 2. Well, if I rewrite this, it becomes a little easier to see what's going on. 3x over 5 plus x minus 1 over 2 equals 6. Well, we got to isolate that x. The only way we can do that is a common denominator. We have to add them together, add these two terms together. So I need this to be multiplied by 5 over 5, and this one by 2 over 2. So this is going to give me 6x plus 5x minus 1 over 10 equals 6. I'm going to multiply both sides by 10 and add the 6x and 5x. So it gives me 11x minus 1 equals 10 times 6 is 60. Add the 1. 11x equals, how did that happen? 6 times 10 is 60. Oh, I didn't multiply the 1 times 5. That's the problem. Thank you, Bella. Okay, so this would have been minus 5, which makes that minus 5. So I would add 5, divide by 11, I'd get 65 over 11. Rational equations contain at least one rational expression. Multiplying both sides by the lowest common denominator of the rational expressions eliminates the fraction and allows you to solve the resulting equation. You must check for extraneous solutions resulting from such a multiplication. So let's see what we're talking about here. If I have 18 over x plus 3 equals 12 over x, if I multiply both sides by x and both sides by x plus 3, I will cross out my denominators. This is better known as cross multiply, because what ends up happening is I get 8x and 12 times x plus 3. Okay, distribute the 12 in. Subtract the 12x to the other side. Divide by 6, and I get x is 6. I check that by multiplying it back in, putting that number back into my value, my x's. So I take my x is 6, I plug in a 6 here and here. 6 plus 3 is 9. 18 over 9 is 2. 12 over 6 is 2. There we go. 2 is definitely equal to 2. Okay, proportions are a special type of rational equation. The product of the extremes is equal to the product of the means. Okay, so let's see what that means. All right. So we solve this big, long, complicated fraction. It's disappearing into poor Winnie the Pooh's balloons. So we're doing this big, long fraction. My lowest common denominator is x minus 4 x plus 1. Okay, so if I multiply both sides by that lowest common denominator, when I multiply it here, the x minus 4's cross out, I end up with x plus 2 times x plus 1. All right, when I multiply it times this term, the x minus 4 and the x plus 1 cross out, leaving me with 30 all by itself. When I multiply it times the final term, the x plus 1's cross out, leaving me with 4 times x minus 4. Okay, now I have everything on one line. So I go ahead and I FOIL this term, and I get x squared plus 3x plus 2. And I distribute the 4 into the x minus 4, and I add the 30, and I have this side. Now, I've got to move everything to one side, get it set equal to 0 so I can factor. That's how you solve a quadratic. This is a quadratic. It has an x squared. So, I will set it equal to 0. And what I did was I subtracted the 30. Well, no, sorry. I added the 30 and the negative 16 and then subtracted that. That would have given me 14. So, 2 minus 14 gives me the minus 13. My next step would have been to subtract the 4x. 3x minus 4x gives me negative x. So now I have this, and now I would need to factor right. Okay, so then when I take that, I factor it, and notice I end up with, I'll do my parentheses, I have x and x. All right, it's hard to see. So let me change this to a highlighter. There we go. Okay, so I have my parentheses, I have x, and I have x. Factors of 12 that subtract to 1 are 3 and 4. So I put my 3 and my 4. My largest has to be negative. So there we go. That's how I factor it. I get x equals minus 3 or 4. The problem, remember I said you have to check for your extraneous solutions or your excluded values. 4 would be a problem. Negative 3 would be fine, but 4 would be a problem. So I would have to exclude 4. All right. Number 8. This slide is a mess. Wow. Okay, so something went forth. Where did we lose that? Okay, what we're trying to do is solve this equation right here. All right, we found our lowest common denominator is 4x times x plus 6. When we distribute this in, when I multiply it times the 1, the x crosses off, and I'm left with 4x plus 6. When I multiply it into the second term, the x plus 6 crosses off, and I'm left with the 4x. And for the final term, when I multiply it to the 1/4, the 4 crosses off, and I'm left with x plus 6, x times x plus 6. 4, and I look at what I have in, oh, look. That was 6 and negative 4. Wait, why didn't the negative 4 work? All right, that one looks much better. Okay. Okay, so that's what our equation must have been to begin with. This up here is how we found it. that equation. All right. So now we have this. We have to distribute the 4 in and distribute the x in. And we're going to distribute the x. And that's where we get 4x plus 6. Nope, 4x plus 24. I add this 4x to the 4x, and I got 8x equals plus 24. Now I get everything on one side. To do that, I'm going to subtract the 8x from the 6x, and that gives me 2x. And I'm going to subtract the 24 to the other side. So that's how I ended up with that. I factor this. Okay, parentheses, x, x. Factors of 24, that's subtract to 2. 6 and 4. The largest is negative, so it's a minus 6. Now, this gives me 6 and negative 4. I go back to my original equation with the 6 and negative. As for a positive, in the problem it asks for, see, positive numbers. Well, negative 4 is not a positive number, so I have 6. All right, if a job can be completed in 6 hours, then 1/6 of the job can be completed per hour. This is how you think of these work problems. The rate of working together is the sum of the individual rates. Sorry, wow. Okay, a large pool can be filled in 8 hours of continuous pumping using pump A. All right, so what we did is we put this into a table. Pump A takes 8 hours, which means you get 1/8 of it full in 1 hour. Okay. Dropped my stylus, and it's very delicate, so it's fine. If a smaller pump B works with pump A, it takes only 6 hours to fill the pool. So together, it's 6 hours to fill the pool, or in 1 hour, it is 1/6 full. How long would it take to fill if only pump B? Okay, so that's what I'm looking for. So I set it up. Pump A. Whoops, let's do the right color. Pump A plus pump B is equal to the two together. Now we just solve for T. All right, so common denominator to get this fraction together. I'm going to have this is going to have T over T, and this is going to have 8 over 8. Oh, wait, actually, they have you do it a different way. So let's do it the way they're showing you how to do it, how your book does it. Okay, so lowest common denominator in this case, this is 2 times 3. This is 2 times 4. So they both have T, so it's 24T would be my lowest common denominator. And so what I'm going to do is multiply this whole thing by 24T. All right, so when I multiply 24T times 8, I get the 8 crosses out, and I'm left with the 3T. 3T plus, when I multiply it times the 1 over T, I get, the T crosses out and I get 24. equals, when I multiply it by 1 over 6, I get 24, 4. I'm left with 4t. I get 4t. If I subtract the 3t, I have 24 equals 24 equals t. So pump B, okay, hang on. Sorry, that is correct. T is 24, which means it takes 24 hours for pump B to empty the pool. So it is a smaller pump. Okay. Oh. All right. So some distance problems can be solved by using rate equals distance over time, or time is equal to distance over rate, and then writing and solving a rational equation. So, for example, we have Andrew drives the first third of the distance from Roanoke Rapids to Wilmington at an average speed of 52. Okay, an average speed of 52. What average speed must he maintain for the rest of the trip if he is to average 60 miles an hour? Okay, so we have... Okay, so we have some equations in here to figure out. All right, we have rate, time, and distance. We know his rate for the first time period, or distance, which is 1/3. The distance is 1/3 the total distance. Okay? The time is distance over rate. My distance is 1/3 d over my rate, which is 52. That gives me this expression right here. Now, for my second part of the trip, my distance, it's 2/3 of the distance because I've already gone 1/3 of the distance. The rate is what I'm looking for, r. And I know that time is my distance, 2/3 d over r. That gives me this expression. Now my total distance, I need my total distance. Oops, I'm going to use a different color. My total distance is still d. My total rate, it tells me, needs to be 60 miles an hour. That means my time is d divided by 60. All right, now, the sum of the rates, so the sum of my two rates has to equal the final rate, because I'm supposed to average 60 miles an hour. So, the sum of the total times has to equal my total time. So I now have this equation. Okay, so notice I have my first third, my second third, and my total. All right, divide each term by d. So now we've gotten d out of this equation because we don't care about the distance. All we're looking for is rate. So we divide by d. Notice I now have my r right there. Okay, so that's what I have to solve for. So I'm going to subtract this to the other side, and then I multiply both sides by 3/2. So I'm going to have this whole thing, and then it's multiplied by 3/2. Mind you, that's not done. You still have r in the denominator. So actually, let's do something a little bit different, I'm thinking. Okay, we're going to move this to the other side, just like we were going to. But then I'm going to make this into one fraction, right? And then cross multiply. If I cross multiply, I get the r out of the denominator and into the numerator where I can solve for it. If I do that, I end up with r equals 65. All right, and now that's your homework. Have fun.